This tutorial is for mile marker 3, practice 1, question 3. In question 3, hopefully we've identified this already as a special right triangle, and it's specifically a 30, 60, 90 triangle. So again, when we're trying to identify our special right triangles, we went over this in the introduction tutorial, but we're looking to see that we're given a side and an angle, and one of the angles we're given, that's not the right angle, is either a 30, a 60, or a 45. So this is our 30, 60, 90 triangle. And we're asked to find a missing side, and in this case, it's the hypotenuse. So if we just talk about 30, 60, 90 triangles in general for a second, they always have two legs, like any right triangle, and I'm going to call them the short leg, the long leg, and then we know the hypotenuse. So the short leg is always opposite the 30-degree angle. The long leg is always opposite the 60-degree angle. And we know the hypotenuse is always opposite the right angle no matter what type of triangle. So the pattern that we want to remember here is that whatever the short leg is, and you know what, I'm going to use the letter y here since we're already using the variable x in problem 3. So let's call the short leg y. If the short leg is y, the long leg is y times the square root of 3. And then the hypotenuse is always double the length of the short leg, so 2y in this case. All right, so if we look at the triangle in the actual problem, we're given the long leg. Now, you want to be careful. Just because it has the square root of 3 in it doesn't guarantee us that that's the long leg. The way we know it's the long leg is that it's opposite the 60-degree angle. All right, so if that's our long leg, that means that our short leg would be 14 root 3 divided by the square root of 3, which is just 14. So that's our short leg. And then our hypotenuse is going to be 2 times the short leg, so 2 times 14, or 28. So the value of x is 28. Now you can also use trigonometry to solve this problem, and if you do, you should still get 28.